Welcome again to Macarium, in a realm fueled by creativity and new ideas. This is the place where visions become reality. In this episode, you are welcomed into the construction journey of a bunker, shown as a comprehensive manual and designed for anyone intending to build a cellar, basement, or foundation structure. The entire area of the cellar is dug out to fit a concrete base situated completely underground with a necessary depth of roughly 2.5 meters. The task is performed effectively using an excavator machine, which is ideal for this job. Wooden stakes are hammered into the earth to define the initial outline of the build. The depth of the foundations, the placement of steel reinforcement, and the final wall heights are all measured and checked against these marked level lines. The foundations are dug to a modest depth of around 80 centimeters. Since the cellar structure is already situated deep below the surface, these foundations are not meant to serve as main load-bearing supports, but to hold the reinforcement grid in place and keep stability during the concrete casting. Concrete is blended on site using a machine mixer with a typical mixture of sharp sand, cement, and water prepared to get a usable and uniform blend. Every foundation hole is filled to about 50% of its depth so the reinforcement cages can be inserted smoothly. The concrete is then poured until the hole is complete. This assists in minimizing fractures and shifting, keeping the concrete steady. Extended reinforcement bars are inserted to allow for subsequent work. Once the foundations are cast and allowed to harden, 25-centimeter spacers are welded onto the sticking out reinforcement bars. These spacers are matched accurately with the set axis strings. The reinforcement grid is then fitted, starting with the horizontal rods. The initial layer is laid straight on the welded spacers, and the remaining rods are arranged at vertical gaps of 30 cm angled braces are welded to the foundation. Reinforcement bars and vertical reinforcement rods are fitted at 30 intervals. Once the reinforcement grid is finished, formwork setup music commences. Every plank is treated with a release agent before fitting, making sure that concrete does not stick, safeguarding the wood and permitting the materials to be utilized again in future pours. Threaded bolts are fitted to lock the formwork, with one bolt placed at the base, one at middle, and one at the summit. These bolts are crucial for withstanding the heavy sideways force exerted by the concrete once the casting starts. Inside the formwork, marine standard birch plywood is utilized to make a smooth, premium finish on the concrete face. On the exterior, OSB is utilized as cladding because this wall will be fully underground. A flawless surface finish is not required. Horizontal wood braces are fitted to withstand the sideways force of the concrete, while vertical wood pieces hold the unit in position and keep it straight. Additional supports are added within the formwork, particularly near the bottom where the concrete pushes the most during casting. If you are watching and liking the construction, please hit the like button and subscribe. It is the best method to support our efforts. Concrete casting starts at the broader bottom part of the wall, letting it settle uniformly as work proceeds around the edge. The concrete is laid in subsequent layers, with each part vibrated to eliminate trapped air and guaranteed full density. For this scale of formwork, 8 cubic meters of concrete are supplied and cast. Any flaws, such as gaps, fractures, or poor mixing, become clearly visible once the panels are taken off. The wall's strength is verified, and any possible problems are spotted quickly, ensuring that the concrete was correctly placed and vibrated throughout music the pour. Work proceeds on the second section of the wall with the reinforcement grid built to complete height. The final horizontal rod is set slightly off level to accommodate the slab above. The slab inclines in 3 directions, falling about 20 centimeters from the middle to music the sides. Even though it resembles a roof, the incline is deliberate. It assists the wall in withstand soil force and makes the cellar more robust. The second section of the formwork is now fitted, reaching the total height of the wall at the bottom. The planks cover the existing concrete by at least 10 centimeters, making a secure seal to stop fresh concrete from leaking through the seam. Fresh holes are drilled through the braces and planks to fit the threaded bolts, because the holes from the lower part cannot be used again. Each bolt is carefully placed to hold the formwork tightly and ensure stability for the next concrete cast. Concrete laying starts with the bottom layer cast slowly around the borders of the formwork. Correctly laying this initial layer is vital as it the formwork and stops bulging or distortion from the weight of the concrete cast later. Stone cladding work then commences. Any leftover concrete residue is cleared using a high water jet, and a heavy layer of mortars is applied to guarantee good bonding. Big irregular stones are selected for their random shape, with no effort made to make perfectly straight or consistent edges. Mortar will not stick well to dirty surfaces, so every stone is washed with a high-pressure water jet to clear dirt, clay, and surface dust. While the stones are still wet, a thin cement mix is brushed on to enhance bonding. There is no use in using premium stone where it cannot be seen. Even so, the stones still need to be aligned level, which is not simple given their random shapes. The OSB panels and marine standard planks are taken off. Thanks to correct surface prep and the use of release agents, the formwork comes off easily. The concrete faces are smooth, clean, and well finished. This proves that the earlier prep and work were done correctly. Stone by stone, the wall starts to take form. The seams not only make an appealing pattern, but also help lock the stones together. Every row is backed with concrete behind. This adds mass and levels out the backs of the stones, helping the next mortar bed spread uniformly and hold tight. A layer of about 10 centimeters of sharp sand is spread over the cellar floor. It enhances drainage, stops shifting under weight, and helps minimize fractures in future layers. The sand is spread with a rake, filling every corner and covering the whole floor. A leveling screed bar is then utilized to refine the surface. Old OSB planks are laid out to stop the top slab formwork legs from sinking into the sand during the next phase of work. Before ceiling work starts, the first job is to fill all the remaining holes left by the formwork tubes. A stiff concrete and sand mix is packed tightly by hand to fill the full depth and set hard. Go ahead. The walls near the ground are still moist, so a flame torch is utilized to dry them before waterproofing. 2 full coats of bituminous waterproofing are then applied, and the aim is complete coverage. Corners, seams, and the base of the walls, where moisture is most likely to gather, are waterproofed with extra attention. Building the roofing slab is a difficult job that needs precise setup and alignment. A string line is fitted along the center of the basement to set the main reference axis. Correct layout is vital because the slab has 3 one from front to back and 2 sloping outward from the center. Tripods with adjustable props are placed and securely locked into position to provide initial support for the slab formwork. Because of the multi-inclined design and the heavy mass of the concrete, extensive wood bracing is needed to complete the support structure for the slab. The areas beside the basement are backfilled in layers. A 30 centimeters thick strip of clean sand is placed directly next to the walls to provide drainage, and the remaining space is filled with clay. This layering helps keep the basement dry and shields the structure from moisture harm. We are installing the remaining props and adding extra support rows. This frame has to hold a lot, nearly 8 cubic m of concrete, plus all the rebar grid and the planks on top. Adding the rest of the props gives full support across the whole basement. Next, the slab formwork is fitted. Large, thick sheets are utilized for the formwork to support the mass of the concrete. Each plank covers a lot of space, which means fewer seams and a lower risk of concrete leaking through. For all the small cuts and random shapes, OSB is utilized. It is a cheaper material to waste. Even though it leaves a rough pattern on the concrete, the gaps are sealed with expanding foam, which prevents poor mixing and strengthens the edges of the planks. Since the excavator is still on site, it is utilized to place the facade stones. Only the front of the basement will remain visible, finished with a stone facade. Inclined stone walls will be built on both sides of the entrance to connect the basement into the ground level and make a solid, natural-looking entryway. Every stone is huge and has to be carefully placed to fit music tightly. Each one weighs a few hundred kilos, and none of them sit exactly right. The work is slow, tough, and demanding. Music greater than the edge formwork is made from reused OSB taken from the wall formwork. Rebars sticking out from the walls are bent down and tied into the slab's rebar grid, locking the walls and slab together as one unit. The edge planks are cut to the right height, so the slab stays level all around the cellar. They are shaped to keep the concrete in position during the cast. The bottom reinforcement grid uses 80 mm rebars, bent to follow the slab incline. On top, 10 mm. Rebars hold the main bars in position. Since the slab is 20 centimeters thick, 2 layers of grid are required. The grid is spaced every 15 centimeters, and each tie is tightened by hand with a simple hook. Pulling them firmly locks the steel in position, giving a solid, stable base for the concrete. Before casting, all mud is cleaned off the rebars and formwork so the concrete will bond properly. A concrete truck and pump bring 8 cubic meters of concrete. Music, even with the slab inclines. The pour is spread as uniformly as possible, using the string line as a guide. The concrete is leveled and screed from the center out to the edges, then finished with a polyrene float. Music work continues on the stone slopes around the entrance. Every stone is cleaned. Loose material is cleared from the seams, and the gaps are filled with mortar to lock everything together. Over time, small cracks will naturally appear and moss will start to grow, helping the stonework soften and blend into the surrounding landscape rather than standing out as something new. The stone facade is built up slowly. After a layer of stones is set, concrete is placed behind it and reinforced with rebars to hold everything in position. Because the stones are heavy and random, only one layer is built per day. The concrete is compacted carefully by hand, using only a simple hand tool to prevent air pockets. No vibration is used, so the stones stay in position and don't get pushed out of alignment. Note, a stone arch is formed at the entrance using a reusable mold. Every stone is carefully selected and music placed to follow the curve of the arch, allowing it to carry its own weight once the mold is removed. Rebars are utilized to tie the arch back into the surrounding walls. Adding strength before the area behind it is backfilled. This slow step-by-step method keeps the stonework stable and well supported. When removing formwork after the concrete has hardened, it is important to take a careful method to keep the structure safe and undamaged. Formwork should only come down once the concrete is strong enough to support its own weight and any extra loads. Usually, the outer formwork is taken off first, then the internal supports. Any props or shoring inside should be released slowly, music step by step, to avoid putting sudden stress on the slab or walls, which could lead to fracturing or settling. Back to the stonework. Every layer of stones is backed with concrete. As the wall rises, it gets harder to work. But with every layer, the facade grows stronger and more securely locked in place. Once the arch is finished, the stonework continues up to a few courses above the slab. These additional layers ensure that when the slab is buried, the stones act as a retaining structure, holding the back filled tightly. The back of the stones is tied with rebars to fully tie the wall into the surrounding structure. Concrete is then placed by hand, shaped to incline from the top of the stones down toward the slab, so water drains properly. The backfill is left just below the stone tops so earth can cover it and blend in once the grass grows. Greater than waterproofing, the slab is done with a bitumen roll. Work starts at the lowest point, so each new sheet overlaps the one below, guiding water down and keeping it from seeping under the slab. The roll is unrolled across the slab with a 15 centimeters overlap onto the wall. Once in place, the sheet is pressed down and partially rolled back. It is easier to work with smaller sheets. Use steady heat. Warm it until small bubbles appear. That is when it sticks. If it is dull, it is